Understanding how rocks break is going to be your most beneficial tool when understanding how to flint knap. If you don't get the physics of how it breaks, you'll never figure out how to break it the way that you want it to. Now, it took me a while, because I was self-taught. It took me a lot of smashing rocks and observing how they break in order to understand how to really flint knap. But to expedite that process, I'm hoping that I can show you some of the things that I've learned over the years and some of the things that I believe are right at the core of understanding how to flint knap. So the first thing I'll share is a Hertzian cone. So if you've been driving down the highway in your car and a rock's hit your window, unfortunately, you've already realized what a Hertzian cone is. So imagine your rock comes, it strikes your window, and then it creates this sort of ripple effect coming out from where the rock's hit. Now, depending on how big the rock is or how much force the rock had is going to depend on the size of this Hertzian cone. Now, with flint knapping, we only usually see half of that. Now, if you can see on this stone here, we have a large Hertzian cone. So the point of impact has been here, and then if you look out from it, you can see the emanating ripples. Now, had the stone not been broken here as well, we would have these ripples coming out the other side as well. Now, from this, we can tell that this flake was struck about here and knocked this off from the larger piece. Now, understanding what Hertzian cones are is important for understanding flint knapping, because we create one of these, or at least half of one of these, every time we strike the stone and draw off a flake. Now, you've probably already gone over the basic flake properties. If you've been doing archaeology for any length of time, you'll understand some of the key elements to a stone flake. Now, like this large stone that I just showed the Hertzian cone from, I now have some smaller flakes of a different type of stone. And they're all rather differently shaped, but they all have some key properties. So, there's the ventral side and the dorsal side. The dorsal side will have flake scars on it. The ventral side will not. The ventral side will be the side from which that has most recently left the core that you've been working. Now, on the ventral side, you'll see the bulb of percussion. And the bulb of percussion has that Hertzian cone on the very tip of it, because that's where that force was applied. In some cases, there will be what we call an Aurelier scar on the bulb of percussion. Some of these stones have it, some don't. This is a residual flake or scar from when the stone was initially struck. So now I'd like to talk about angle and force. So here I have a spall, and I'm not going to go breaking this in the living room as much as I'd like to. And it's really cold outside, so I'm not going to go out there either. But I think I can demonstrate what I want to by using a Sharpie and this paper here. Now, imagining this is the core we have, let's talk about how to break it. First of all, though, too, we want to maximize or keep our width and our length. while removing some of this mass, right? Like if we were building, or if we were creating a large Clovis point or a paleo biface of some sort, we want it to be wide, long, and rather thin. So I want to imagine us, rather than breaking up this rock to get that desired result, peeling layers of it away to get that result. So imagining right in the center of this is our large paleo biface, but we need to peel off layers. We need to peel off flakes all the way around the circumference of this in order to get it thin, long, wide. Okay? Flakes from a different material, but imagine them peeling away from the stone as I go and work around the surface. Okay? Now this is where angle and force come in. So now picturing this stone, I'm going to draw it on here. Rough idea of what it looks like anyway. Okay, and we're going to draw it a couple more times. Probably going to look a little different each time, but that's okay. I just want to demonstrate angle, okay? We're choosing this as the platform, okay? Now, remember, I want to keep that width and length on the top. So I need to choose where to strike this stone to remove layers from the bottom. Now, if my angle of force were to be right here, imagine that this flake I'm going to peel away is going to be that much. Okay? That's what happens when I come in from this angle. Here's my platform, and I'm coming in at this angle. I'm not going to take a very large flake off. Okay? So, if I want to reduce this mass, but keep this area up top, I'm going to have to choose my angle a little more wisely. If I come in just slightly less, like this, I may be able to get more or a larger flake off the bottom. Okay? Also, choosing where you strike exactly is also very important. Because if I strike up here, I'm going to lose some of that area on the top, and it's going to be a much thicker flake. But if I just focus right on the very edge here, and this will take practice, it's going to be a much thinner flake. But also the angle which I choose will determine how long, how thick, and how thin that flake is. Okay, now let's imagine that, so we didn't get enough flake off here. We got more flake off here. This is probably a good angle. But let's say we changed it a little bit more to even less of an angle. And we came right on that platform with, let's say, the goal of getting right through the piece. That would be nice, wouldn't it? We'd lose a lot of this mass while keeping the width and length up here, and then we could work it into our Clovis point or whatever. But the issue here is we're going to need a much greater amount of force to draw this thick of a flake off, because that force needs to go through the stone like this. You're going to need a hammer stone and some serious biceps to strike that and get it through. And more often than not, it's not even going to happen. You might strike it and it may fracture a bit here or crush, creating all these little micro fractures in here, which are going to be a problem later. Maybe you strike it hard enough and it goes right through and it's perfect. But the issue with this angle is if we're even a little low here, could come up and take our whole piece off like that and just leave us with this. Or could strike as far as our power gives us, and maybe it's only this far. And then we just take a big chunk out of the stone instead. So knowing your angles is very important. And this is something you'll learn over time as you flake. And each platform is going to be unique and at a different angle. But the beauty is if we're comfortable with a certain angle, then we can manipulate the stone to create that angle. So if I hold the stone like this and strike here, I'm only going to have a little bit of flake off the other side. But if I hold it like this and strike here, then I may be able to draw a larger flake off here. So, continuing this story, we're figuring out angles, and we're figuring out how much force we apply. It's tricky because this isn't 3D. But imagine now that we've figured out our angles, how we want to break this stone apart. So we're coming in here, we're drawing that much flake off. Then if we tip this piece up, we can come in here at this angle, peeling that off. Hopefully these two connect. And then each time we create a new flake, it's going to have ridges on either side of it. And those ridges are probably going to meet up at a point around the edge of the core, creating new platform, new platform, new platform. And eventually, as you start working around the piece, you get to a point where, let's say, it becomes bifacial or at least unifacial. And like this small blade I have here, each new flake scar creates a ridge and a platform for the next. And then we can just start following the piece down its edge. If there's a part in the stone we think is a bit too thick or unshapely, that's where we work. And if we encounter step fractures or whatnot as we're going, generally we can come at it from the other side to remove those. But we'll talk more about that later. So I wanted to take a minute to discuss conchoidal fracture. For flint knapping, any of the stone materials that we're using need to exhibit conchoidal fracture for them to work predictably. So I'll start with this piece of mahogany obsidian here. And if you can see, if the camera would focus in on this, it has all those rings. Now we're looking at the ventral side of this flake. And the term conchoidal fracture comes from just that. This kind of resembles a shell, a mussel shell, or think conch shell, conchoidal fracture. Now, depending on the type of stone material, this conchoidal fracture is going to look different. So very easy to see the ripples on this piece of obsidian because it's very fine grained, but much more difficult to see on this large quartzite flake. If you get the right shadows on it, you can still see that it rings out like that, but much more difficult to see. Now in this piece here, we're also looking at that ventral side. That's where we're going to see those ripples. When I hold it at just about that angle, you can see them. And of course, this is our dorsal side because we have some flake scars on it. Okay. This nice big piece of Montana chert comes from the I think I wrote it on here somewhere. California Creek Quarry in Montana. This piece I like because there's a large scar right here that exhibits perfect negative image of a flake, and it's showing us that conchoidal fracture there. Now you probably can't see it on the camera, but if you were to look even closer at this piece, it's covered in Hertzian cones. It's also been sitting outside for probably thousands of years in exposed, so it's all freeze cracked throughout. So as much as this is great material to work to make stone tools, if I were to take a large hammerstone and smash this, it's likely that it would break into a lot of very small chunks that may not be that useful for making a biface or arrowhead or whatever. We could probably get a few little Avonlea or old women's points out of it, but that's that. Looking at some other things here, this is also a piece of Montana chert, obviously different color. This comes from the Logan Quarry, and you can see here that I've chipped some along here, but it looks like we have both a quartzite or something that's going into this chert here. And so those conchoidal fractures and those flake scars look rather different in this very fine-grained chert type material here as opposed to the quartzite here. Piece of siltstone or mudstone, more likely siltstone from the North Saskatchewan River. Again, we can see those flake scars all the way around the edge of this piece. So this stone is going to become a core, or it already is a core, because you can see a large flake has been driven off from here, and from here. But here is the ventral side of this flake. And right on the end here, you can see the Hertzian cone. So this being the ventral side of this flake, on the dorsal side, as there are scars here. Another one. Here's the bulb of percussion. There's a small scar within the bulb called an Aurelier scar. And another one. Ventral surface, dorsal surface. Proximal end with the bulb of percussion, the Hertzian cone. Distal, where it feathers or hinges out. So when looking for the dorsal surface, always remember there'll be flake scars on it. Ventral surface won't have any. Let's take another large obsidian spall here. And imagining where this originated. A lot of the bulb of percussion is now gone. There's some leftover Aurelier scar here. But this is where it was struck from. You can see if you turn it on an angle, you can see the bulb. Ventral surface. And here's our dorsal surface. Flake scar here, 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 here. Now this flake scar is rather beautiful because it shows us the negative image of a flake. The bulb of percussion, it was struck from here, coming this way. The distal portion of the flake, proximal portion of the flake. And that dorsal side of this flake, wherever it is now, probably turned into an arrowhead, would have either flake scars or some of this cortex on it. You can notice, or you can see that this obsidian still has a weathered surface on it here. Now, the platform for this large flake was right here. And imagining that my fist was a hammerstone, struck just like that, peeling away this flake. Had it have been struck just a little bit harder, the flake probably would have continued through this bit right here.